Hi, I'm following along with Paul McCorder's Raspberry Pi Pico W lessons. He's on number 41 and he's messing with the IMU on the that was included in the kit and uh, has an accelerometer as well as a gyroscope in it. So um, he's showing it that he's got it wired, and I guess he's going to go in and show us how to use the uh, OLED screen as well on that. And um, he's got it wired up and left us some homework to play around with how to use the Earth's gravity and the accelerometer to try to estimate what your tilt is of your breadboard. Um, I was going to do it that way, but I got to be honest. I've been playing with these little M5 sticks that I purchased. I had a video last time on it, a couple of videos on that. I mentioned them. This is a $10 package here, and it's got it's uh, ESP32, not the RP2040, but it still runs MicroPython, and it's got an IMU in it. It's got a color OLED screen in it, which is kind of cool. And it also has a battery, so you can actually run this without being hooked up to the computer. So they say that there's a way to use this with Thorny and use it with regular MicroPython. I tried going through, they have pretty good instructions on how to do it, and I'm either missing something or something's changed since they made the instructions, and I couldn't get it to run on Thorny. But fortunately, they have online web-based IDE to program this thing. So let me go up and I'll show you what I've been working on it. So this is your IDE that you get with it, and um, it's another cool thing about it is that because the ESP32 also has the radio in it, the Wi-Fi in it, that this thing actually does the updates over the air. So you don't even need to be connected to USB to upload programs to it. Sounds pretty impressive for $10, and it is, but it does have some downfalls. Like I say, it's got a battery in it, but the battery with the screen on only lasts about 30 minutes. So it'll work good for some things, but you better be prepared to plug it back in and charge it back up for an hour or two after you've used it unplugged for a while. Um, Another thing is because of the small size, it actually only exposes 3 IO pins on it. Um, so, you know, it's limited that way. But it also has the I squared C connector that Spark Fun and Adafruit and all those have gone to putting those on their little breakout boards that they're making. So you could hook it up to pretty much anything, I guess, as long as you can get a library in. I haven't tried importing regular libraries into this, and I'm not into this web interface, and I'm not sure whether it takes all libraries that you can find on it. Um, but if you can get the Python part of the library, you should be able to just include it, I would think, but I'm not sure 100%. But anyhow, I just wanted to show how I went about setting up the little uh, tilt thing to get the tilt of the little container that we got here, about the size of a pack of gum. So we'll go over the code a little bit. So like I said, this is their version of MicroPython, so it's not exactly, and it has some libraries that they're using that are not generic. They're tailored just for this. Yeah, the M5 stack library module. You got the UI module, which is um, the one that allows you to put things on the screen. And it's it's much more handy than trying to use the OLED library on the regular OLED. And then there's UI Flow. I think this is the one that allows it to do over the air updates. And that's kind of cool. And like I say, we're using the IMU and time and import math down here a little bit later because we're using ArcSine and things like that. So we'll skip this part. This is part for drawing, and it's easier than you think when you got that when using this IDE. So we got our while true down here, and we're doing our math.arcsine, and we're reading the acceleration of the IMU, getting the X and the Y down here both. And I've seen other people doing some videos on it and using that and showing how you end up with a error if you go not past 90. But what happens when you're at 90 and you might be jiggling your accelerometer a little bit more and you got more than 1 G of acceleration on that, and that messes up because ArcSine is looking for something between -1 and 1. So I take care of that by doing doing a max min thing here. This is the Python way of constraining it between two numbers. If the acceleration is less than -1, it makes it -1. If it's higher than 1, it makes it 1. And I've showed this on a couple of my other libraries or my other projects that I've done where this max and then nested inside of a min, a max nested inside of a min. And that's going to constrain it. So we got that. And then we use our math.pi times 180 to get our convert from radians to degrees. So that's kind of cool there. You could normally it's 2 pi, so you're doing the 2 pi over 360. So we're doing pi times 180 just to simplify it a little bit there. So we're getting both the AX that be degrees, and we're getting the AY in degrees. So that's what we're getting there. And what I'm doing is displaying this circle on this screen with based on where it is. Now, I tried it by going 90, degrees and stuff like that, and it works, but you're not going to be able to look at your thing if it's 90 degrees. So I decided to make it 45 degrees. Just the full scale of this is 45. If you're tilting 45, your ball is going to be up here. And if you're tilting 45 the other way, your ball is going to be over here. And I just felt that got more movement out of it for what we can see on the camera and everything. So that's why I did that. You could certainly change these in here. And then on my Y value, I noticed that it was going the opposite direction. So I just made this negative, dividing by -45 to do that. So that got it so direction was going the correct way. So we're setting our circle position when we do that. And like I said, this has I'll get up back there with the circle, and then we got the 2 lines. And found that you had to draw the 2 lines each time, or this doesn't have a show on it. It must be built in that each time it goes through the loop, it's going to do a show. But I did find that the lines kind of got the pixels disappeared on them unless you showed this line every time. So each time through the loop, we're going to reset this line, the line, the cross line here and the vertical line there. So anyhow, that's what I got going on right now. And oh yeah, I wanted to talk about this. So the circle and creating these is really cool. All you got to do, you just bring in these things over here. It's sort of a drag and drop type thing. So I'm going to drag another circle in, and when I do, you'll see over here in the uh, code, it's automatically going to create another circle. So there, create another circle, and this is the position that it's in, and this is the color, and then you also can do the outline color. Now, if you wanted to change that without doing the numbers, if you wanted a graphical way of doing that, you can click on it, and you can change the X and Y center position of it as well as the radius. We could go 5 for the radius and make it a small one. And then the color is you're pulling it out of this grayscale or this color chart here. So you just click a couple places, and then once you get the color up there, you can say okay. And that's actually the border color, and that's not the fill color. They call it border color and background color. You know, we would call it fill with the other one. So let's make the fill green, I guess. So we'll make it green. Yeah, so that. And then, like I said, you know, I just created that X out of that. But if you don't want to use it, it's as easy as throwing it away, and you can watch that the code actually updates and it takes that code out. So that's kind of cool. I know that a lot of times that we would like to have different size fonts on our text on these. They call their text labels instead of text. So you can just drag or drop a label, and it tells you where the starts at. Or I don't know where it's the bottom. Must be the bottom right, I guess. Bottom left, I think. I'm not sure where that is, but we could probably figure it out. No, it's the top because it's going out. It's 0, 0, so it's the top left. But anyhow, we can click on that, and we can change the font size. They don't have everything, but you can change it to certainly make it bigger, and you can rotate the font 90 degrees. You know, move it wherever you wanted to. And you can see I already have a text box there, and you can update the text in it anytime you wanted to, you know, by, you know, label.text and change it, you know, just like we're doing circle.position, set position, probably set text or something. But anyhow, and it gives you the font, and you can have whatever color font you want and everything. So I didn't change the font color, but you can make the font color. I'll make it yellow. It automatically updated it there. So again, so I kind of like that, like this, and it makes things easier. And I think I've mentioned before that I teach coding to teenagers, and I think that they would get a head start on learning this. It might slow them down if they ever have to go back to regular coding, but I sort of like it doing it that way. But anyhow, that's what we got going on. But to be honest with you, all this Python code here, I didn't actually program this in Python. Like I say, I teach kids, and a lot of times I teach them with the Blockly style. And this is the Blockly code that you need to do the same thing as the Python code. So I actually pulled in all these blocks which do the same thing. Your variables here that you're setting, and you setting the variables here, getting your acceleration, and like I said, they're using constrain here, so that's, you know, they have a constrain block, and then we're using the if block, and we're saying if the absolute, I didn't mention this in the Python, but if the absolute value of the x and the absolute value of the y is less than the differential, then it's going to change the color of the background of our thing to green. Otherwise, it's going to be red. So that way, when we're level, dead level, that we can have uh, uh, a, a visual inspection. When it gets close enough to level, you could change this to whatever you wanted, but uh, when you get close enough to level, it's going to be within so many degrees of level, you can change it. And this is the part down here that sets the circle center X based on the tilt, or the, your tilt that you get up here based on your acceleration, gravity. And this is the same thing where the screen width here is 80. So the center of it would be 40. So that's why we're doing this. So we're multiplying it by 40, and then to get the full stroke here, we're going to, like I said, I only go to 45. If you go farther than 45, it goes off the screen, and it doesn't crash the program, which is cool. But then we're multiplying by 40 and then dividing by 45. And then to get back to the center, we're adding 40 back in to get back to the center. And we're doing the same thing with Y, but we're 160 here. So we're half of that is 80. So we're doing 80. And then, like I said, it's 45, but I had to add the negative in to get it to go the correct direction. And then we're adding 80 back in to get it back into the center. And like I said, then you'd redraw the line each time through, because it seems to erase it if you don't. And then we're only doing the loop every 200 milliseconds, so 5 times a second, which is plenty. And it's kind of cool. So I can actually show it running. I now got to bring up my code. So we don't get any kind of, once you run it, you don't get any kind of live update up here. This is just the static of where you put it. And we're changing it down here in our code, but it won't change up there. So let's see. I got a camera down here. Let's see what we got. All right, so you can see we got the camera. We're gonna get in the center there. Holy mackerel. There we go. It's kind of changing, but there you can see the dots in the center. And my computer's not quite level here, but I'll bring it up just a little. Centers. I can say it's got to be 3 degrees, but then when you go off center, it stays red. So, and then, like I said, this has got a battery in it, so I can unplug it and it works fine for a half hour. That's what the code does. Anyhow, let's minimize this camera, and I'm going to show about the live updates now. So let's go to the Python side, and we're still, like I said, the circle has a color of white right now, but if we can change that, I can change it either place. I could go up here and change it background color here, but I can also go in here, and let's say I wanted to make it blue, so we got RGB. So if I make these last 2 zeros FF, and then I hit this run button, like I say, I'm not plugged in. Let me prove it. I'm not plugged in. But then if I run, shows that it's executing the code. And if I bring the camera back up, still not plugged in. Uh-oh, it didn't do it. What happened there? Oh, it changed. No, it didn't. Circle. Oh, I changed the color of the background. That's what I did. Oh my gosh. So let's make that was black. That's the outline. So I need to make these first four 0. 0, 0, 0, 0. And it didn't change it up there. Wonder why. Maybe I have to change it to this. So I want to make it blue. Yeah, let's just do it here. So it's 0, 0, 0, 0, FF. And then okay. All right. So you can see it's blue there now. And now it's the same thing we had there. So evidently you can't go in, it doesn't follow through. So now let's do it. It's connecting and successfully did it. And now you can bring up the camera. So as you can see, I'm still learning about this. So now we have a blue dot. And like I say, it never got plugged in. It's on over-the-air updates, which is kind of cool. So the only thing we changed here is the color of the ball. Doesn't look as good, red and blue on green, but that's okay. Anyhow, like I said, my computer, there we go. My computer just table it's on is tilted just a little bit. I saw Charlotte said her house, the whole house is tilting. I think my house is pretty level, but the table it's on is a little flat. Anyhow, that's my homework. Way too long, I'm sure, but it's been a while since I did a video, so I'm a little rusty. Thanks for watching. Have a good day, everybody.